Hello. I welcome my fellow ISSF Shotgun Committee members. My name is Jack Birch. This is Ken McGehee. He is my Chief Range Officer here in Kerrville. After the last meeting, we talked about doing a video for you on the system that we use to set our trap targets, but we also kind of modified this system to be able to use it for our skeet targets as well.
Jack, where did you come up with this system?
Well, it's actually not my system. We call it the Brantley system because a gentleman by the name of Maxie Brantley, while he was stationed in Fort Benning, Georgia, somewhere around 1983 to 1985, he was just looking for a better way to set targets. So instead of using lines or poles or having somebody standing at 76 meters and somebody else doing another thing, he came up with this idea. Now, the problem at the beginning was that they didn't have the equipment to do it properly. So they didn't have a good speed gun, they didn't have an inclinometer, and he tried different things, and it really didn't come to its own until somewhere in 2000 to 2005 when we started to develop equipment that we could use and it was available to everyone. So that's kind of where it came from.
Okay. Tell me the purpose of this. What's the equipment that you use?
Okay. Well, obviously his purpose is that there's a couple of things that is a challenge to setting targets. One of them is weather. So if we get any wind, it can just make it very difficult. You know that. You've set a million targets out here.
Yes.
But it's also the speed at which we set targets. So I was just in Santiago, Chile, for the Pan American Games, and it was taking them an hour to an hour and 10 minutes per bunker to change the scheme. And this is just, when you have 5 to do, fortunately we only had 2, it just is a very bad situation for us. Those are 2 of the big things, but again, the field differences. So I don't know if my colleagues can see behind us, our terrain drops off so much. It's a 30 to 40 foot drop out at 76 meters, so it's kind of difficult to tell, what we're doing. Also, what the athletes seem to like about it is a 2 meter target on a difficult field, and you go to a 2 meter target on the same range that's, say, very flat, they're the same target by using technology instead of the system that we have now. So that's some of the reasons behind it, but there's one really, really big thing that range owners and operators should be looking for: the usage of targets. To set targets, it takes us somewhere between 45 and 50 targets per field to set height, distance, and the angles. And we've had this checked by, as a matter of fact, by Mr. Brantley. Came in and looked at it, and that's our average. It was 49 actually was the average. So I've seen upwards of 300 targets used per field to set the targets the way it is done now with ISSF rules. So, it takes us, you and I have been doing this together for quite a while, it takes us about 20 minutes to set a field. So it goes really quickly, and so your staff is not out there till late at night.
Perfect. Yes, I remember setting many fields till late at night in the wind and had lots of complaints. This is something that's very consistent because, like you said, our range, even on our range, from field 1 to field 8, there's 40-45 feet of difference between there. So it's very flat on one, and to the other extreme there is a huge drop off. So it's consistent speeds, consistent targets for the athletes, makes it a better experience for them.
And again, here we have a problem with wind sometimes. So whether it's coming from the north, which is the way the camera's facing now, or from the south, it changes these targets quite a bit. And we can actually set these targets in gale force wind, and when the wind goes away, they're going to be correct.
Right. Can you show me some of the equipment, or show our fellow folks what equipment that we use to set these?
Absolutely. Let's take a look at it. So we're back to the equipment, and then there's several pieces of equipment that we use. Some of it's already used in setting the targets the way ISSF says. We'll get to that in a minute. But so let's start with our speed guns. This is actually what sets the distance. Of course, the distance is set a combination of the height and the speed, but this is one of the places that we start. So the Bushnell radar gun. What's good about the Bushnell is it's a pistol grip type. It's easier to hold. It has a little bit wider range, so it's a little easier to catch the targets in the beam, if you will. The downside of it is if you're having to travel with it, it's a little bit more bulky. I found it not to be too much of a problem. And if you'll notice that for our skeet, when we'll talk about skeet in a minute, we actually put our information on the top so we don't have to chase it around and wonder what it is. Now, I've been traveling a lot, so I was looking for an alternative to carrying a bigger gun. And that is it's called a pocket radar, and it's called a ball coach. And so you can see it's a lot easier to carry around, way more portable. But the downside again is that it has a narrower beam, so you're going to have a little bit more difficulty catching the target coming out of the machine. We've learned how to do it. It's just for new people who have never done this before, it's probably just a little bit more difficult to use. So that's how we get the speed. So the next thing we use is called a digital inclinometer. This is just really a digital level. This is one of the big stumbling blocks that Maxey found. He just could not get a decent, accurate way to measure the angle of the machine. And so we found these. You'll note this one's a 2-foot level. You can get the bullet levels, which are much smaller. The longer your level is, of course, the more accurate it's going to be. But I have to tell you that it's only going to be like a 1/10 difference, and that's really not enough to worry about. Because if you think about the way that it is done now, sometimes you'll see the ropes out or the strings out, and they're set at every half meter. And so there's just really no way to tell that you're being like a 1.5 to a 1.6. With the digital level, you're pretty accurate. And I don't know, Ken, if you can zoom in here and not be able to see this. I'm going to turn this on so you can kind of see that this is down to a 1/10 of a degree. So it's actually pretty good, and it's really reproducible. So the next thing, of course, we have is an angle finder, a protractor, if you will. And everybody has these, everybody uses them. We prefer to use a larger one because when we set this on the bunker over each machine, we can set the degrees that it's supposed to be here. And then if we're not exactly over where that target's coming out, your eye will read parallel better than it will read a direct angle. So I'm going to stand this up just a little bit so you can kind of see. And you see that it's marked out to half or 5 degrees from 0 out to 45. We actually go to 50, but we, of course, never use that. Of course, the two other things that you need on the field are the distance marker to 76 meters, and you need an elevation or a height measurement. We use a pole that's got from 1.5 to 3 meters in a tenth of a meter, and it's very easy to use, and that's kind of what we use. Once a field is done, or once a range is done, you really don't need them anymore, except about every 5 years, just to double check the data to make sure nothing's changed.
Jack, can you tell me how you develop the data for each range?
Certainly, that's one of the challenges of the Brantley system. You can't take what the information we derive here and say, go to Santiago or go to Italy, because the data is just not going to be the same for a number of reasons. You have difference in machines. You have differences. There's a possibility that you could have the same manufacturer and a newer model machine versus an older model, and it may be different. So each range must develop their own data, and it's very, very simple to do. You set the machine to a direct going away. You start at 1.5 meters. You have somebody at 76 meters. You get the 1.5 meters. You get the speed, and then you check it with the radar gun and with the inclinometer. And you can do that on one machine. It doesn't take that you have to go through all the machines. Just need one. So once you develop that data, you can put it in a spreadsheet. That's what we use, and I'll show you that spreadsheet in a minute. And then all 9 schemes are set up for that range. If you have a different field that has to have its own data, you can put that on a spreadsheet just for that field, and you go from there. And so you're doing it in tenths of a degree of elevation, and it's not a degree, it's tenth of a meter. And so you start at 1.5, 0.6, all the way up to 3. And once you develop that data, which takes a couple of hours to do, and you have to find a calm day to do that, and you kind of go from there. So now you have the data. You have all the schemes set up. Again, I'm going to show you what this looks like, and you kind of go from there. So developing the data takes some time, takes some expertise, but it's pretty easy to do.
So let me get this straight, Jack. If we had a bunker and we had different types of machines, say in bunker 8 we have Matarellis where we have Laportes here, we'd have to develop the data for that bunker specifically also, correct?
Exactly correct. And the real challenge there would be like Colorado Springs, USA Shooting's home range. They have one set of every machine. So they would have to go and do all 5 bunkers, and that's okay. It doesn't take that long, but they would have to do that. And again, I need to stress that the data that we develop here cannot be just unilaterally used anywhere else in the world. Now, are they going to be similar? Yes, they will be, unless you have a huge difference in the sea level versus, say, Colorado Springs, which is 5,000 feet. So their data is going to be completely different than what we have here.
Right. Okay. Okay. So, shall we show them how we do this?
Absolutely. Okay, Ken, so let's start talking about the setup to doing this system. What's the first step in it?
All right, first step that I do is I come into the bunker and I disarm all the machines the very first. And then I go through and I loosen all the bases of the machine, the nuts that hold, the bolts that hold the machine in place on the angle. And then if our particular machines have a jam nut right up here, and I go ahead and loosen that so that we can set the speed easier.
So if you have a third person to do this, a lot of times it's just you and I. If we have a third person, can we have them go ahead of us?
Yes, that works great. Is we disarm them, I'll tell him, or we'll tell him to loosen the nuts and the jam nuts. He'll go start doing that, and then I'll start. First thing I want to do is when I come to the machine is I want to look at the cant of the plate. If it's canted to one side or another, and that puts the hook into the target. So I'll look and make sure that they're straight before I do anything else.
And so we're clear that that's so the target is flying flat through the absolute most part of its target path.
Correct. Yes, sir.
And one other thing that I've noted around the world is that they call that banana. So if you hear that, that's what we're talking about here. So kind of go ahead. I don't know if the committee can see how far that plate is canted to the left. We tried to take a picture of it, but it is pretty far off. And so it's like 3.7 degrees to the left. So Ken's going to kind of take a minute and get that level, and we'll show you that here in just a second. So Ken, now that we've got the cant out of the machine, what's the next process? How do you actually get an accurate, consistent height degree on this?
I looked for the flattest place on the plate of the machine. Each one's a little bit different, but on these Laportes here, right in this area right here is a flat place. So I'm going to put it here, and I'm going to line up the bottom of this right with that flat place. So it's flat on flat. That gives me my consistent reading.
Okay, and what are you reading right now?
I am reading 16.0.
Okay, and so if we were trying to set this to a specific angle, height angle, what would you be looking for?
I'm going to be here's one thing I do want to back up and tell you. You need to be the first one, if you're working with somebody else on setting the angles, you need to make sure you're about 5 to 6 machines ahead of that person. And here's the reason why. If they're throwing the machines further down, it shakes these machines, and you will not get a consistent, because it'll be bouncing around all the time.
Okay, so our data here shows that a 2-meter bird, and that's what we're going to set here for our folks, is 16.9 degrees vertical angle. So kind of walk us through what you do there.
So I'll leave it on there, see where I'm at, and I'll start adjusting the machine up, watching my meter. And about now, I'm just now reaching 19.5.
Okay, we were looking for 16.9.
I thought you said 20.
No, 16.9. See, and this is how it can get a little confusing. So a lot of times we'll have an extra person in here reading these height angles to Ken, and it just makes it a lot easier.
So now I'm at 17.0. I need to go down to get that, and I do it in small increments on the turnbuckle.
The nice thing about the Laporte is you've got quarter of a turn increments on the turnbuckle here, which makes it very, very, very nice. Okay.
I reached 16.9, and did it turn off?
No.
I reached 16.9, and I want to let the machine settle and make sure it doesn't move and recheck it. So with the movement that the machine was bouncing, I'm still not accurate. So I need to bring it back down a couple more turns. You want to be as precise as possible to make the best target for the athlete. And I am at 16.9.
So that looks really good. So, you just do the same thing all the way down, and typically, as you said, what we've found is I let you get a couple of stations ahead of me. So, like through station 2, before I start doing the speed check, and I think we'll show them that next. Okay, so now we're going to set the speed. And again, these two work together as they always do to get the distance and the correct height. So here we have our Bushnell. I'm going to turn this puppy on, kind of give you a look at what it shows. And so I've got a big screen in the back here to watch and see. It's no big deal. So let me kind of show you how I do this. I do this very carefully because I don't want to get hit by this arm. So talk this machine. I like to, because this beam is rather wide, I can do this. I like to get up above the throwing path, and I'm going to catch this. So all I got to do is hold the trigger down, trip the machine, and I don't know if you can see this or not, but that machine was running at 60 miles an hour. So all we do is adjust the spring in the back and get to 62, and we're golden. I've had the question, well, what happens if you're 61 instead of 62? I would work to try and get it to 62. The more accurate you are, the better it is for the athletes.
I have one question for you, Jack. What about the arm coming through there? Can the radar gun catch the arm and give you a false reading?
It can. That's why it's very important that you keep it above the arm, and it will give you a false reading. But you're going to know it because it's going to be in like the 20s versus the 60s or 69, somewhere along in there. So right away you can tell when it's wrong. So the last step in the process, of course, is setting the horizontal angle. We do this according to the rules, but we also set it over top of each machine so we can get a parallel target with the arm. You'll also notice that our protractor has a pretty good lip on it so that we can set it right over the front of the bunker and get it to be exactly correct. This is machine 11 in this particular sequence, so I'm setting the angle on 10 degrees. That's what it calls for. And Ken would normally be down in the bunker, and I would call pull, and he'd throw it. We'd adjust it left and right and get the angle. It's very simple. Everybody knows how to do this. So Ken, that's kind of how we set these targets. We've been doing this, gosh, probably 10, 12 years now this way. When Maxie came up and brought this to us, we were on board right away. Now, interestingly enough, as I show people around the world how we do it, they immediately see the benefits that this system does.
It's great. I have to say, from my experience, especially on this range, this particular field, the south wind during spring, summer can come through here and push the targets down where it makes it a real challenge. So it is a great system, and we have a lot of compliments from the athletes on the consistency of the targets.
And after all, isn't that what matters in this case? We are here to serve the athletes and make it the best, most fair that we can. So I want to talk a little bit about what we did with this system, and since we found out that it works here, we decided let's see if it'll work over on the skeet fields. So we did exactly that. We did a very simple process. We typically set the high house to speed first, then the height in the hoop. Then we go to the low house, set the speed, height in the hoop, and then we just look at the crossing point to make sure that it's crossing just a little to the right of center. It's very simple. We're using the same types of machines, and boy, it's just really simple to set the skeet that way. Once again, we can do it when there's a lot of wind. Now, it's a challenge still when the wind is blowing where it's blowing them up and down, but we can still get consistent targets even then. So if you have challenges like, I'm going to use Santiago as an example, field one was up against a bluff, and so we could not get the low house to fly the distance. With this system, we were able to get the speed correct, and even though it didn't make the distance per se, it still was the correct speed. And once we started setting the targets this way, the athletes were very happy with it. So that's kind of how we do skeet. It's really the same system, just a little bit different numbers, small procedure difference, and we kind of go from there.